Okay, we are continuing May, June 2023, variant 41. We stop at 7A. Right, we have answered this part there. Wavelength associated with moving particle. There's your apparatus for electron diffraction. There's your observation. State the name of the phenomenon demonstrated by the pattern shown in figure. Right, there's your figure. We say it's electron diffraction. Explain what can be concluded from the pattern in figure 7.2 about the nature of electron. Okay, this is where we stop. Yep. Explain what can.
Uh, okay. Light, light and dark regions of the concentric circles are diffraction patterns.
2 mark. Make sure you got 2 points.
So the electron is behaving as a wave.
Beam spreads out, indicating diffraction, or light and dark region indicate interference pattern. Electron beam behaving as wave. Okay, you're right. Electron in B is now accelerated through a greater potential difference between the cathode. Sketch the pattern that is now seen on the fluorescent screen. I can argue it out lah. Would the wavelength be shorter or longer?
Mm,
There's a kinetic energy of electron. There's a accelerating potential difference energy. Electron be accelerated to a potential of V, and that is if all the electron behave as wave. So this is your lambda. So your lambda will become increased V. The lambda becomes smaller, right? You see the concentric circle there. Explain with reference to the right? That is for your diffraction of light through a circular aperture. Explain with reference to the body wavelength, the change in pattern in the fluorescent screen. Right? Lambda equals to h over p. Wavelength is smaller. I can argue as momentum, as energy increases, momentum also increases. So wavelength becomes smaller. Center bob and concentric ring bring closer together than previously. Right? Greater PD, so electrons have greater momentum. Greater momentum. Right? Greater PD, greater momentum. Greater momentum, so decrease in wavelength. Wavelength smaller. Lower the Brody wavelength for the same diffraction grating spacing. Increased causes a smaller diffraction angle or smaller angle of intensity maximum and in each order. Decrease in fringe spacing in diffraction grating. Sorry, decrease in fringe spacing in diffraction pattern. Okay, Ken?
mm.
Table 8.1 shows some data related to properties of air, gel, body tissue. The data are given to three significant figures. Show the acoustic impedance of gel is 1.68 times 10 to the power 6. Right? This one. So you just use your formula. Z is rho times C. Rho is 1,200. Speed is 1,400. That's what we have shown. Complete the table by calculating the missing value of the three significant figure. Use the space below for a working. And there's a working for air. Right? By just using this formula, rewriting it, get 1.2, 1.29. And you want this one we already calculated. Now we calculate the speed of sound. Right? This one is given, calculate out, and fill the table. They're not interested in your working. They are just interested in your result. Even though they give you space to do a working. Any comment?
No.
Okay, we're all right. Let's carry on. Use your information in A to calculate the intensity reflection coefficient. There's your formula given your formula sheet. Okay, Z1, air and tissue. So this is a 2. Z1, Z2, 0.99. Gel and tissue. Approximately 0. Okay, any comment?
Okay.
Mark yourself. Use your answer in B to explain why gel is applied to the skin during the ultrasound scanning.
Without the gel, like right, almost all of the incident ultrasound is reflected from skin.
Okay,
And then with the gel, the ultrasound is transmitted into the body.
100% transmission. With gel, almost all of the incident ultrasound is transmitted into the body. Carbon 14 is radioactive and decay by beta plus emission to form boron 11. Carbon 14 has a half-life of 20 minutes. Boron 11 is stable. Define the half-life. Okay, why is the half-life?
Half-life?
All this should be by your fingertips.
Time like the time taken to reduce.
Reduce
No,
what?
activity to reduce half of its original value.
Okay. Time for activity of sample to half its original value. Okay. The sample contains N0, carbon, and no other nuclei at time t equals 0. Figure 9.1 sketch the variation with time of the number of boron 11 in the sample. So we start with this one. Carbon 11. So boron is 0. So this one will go to half. Carbon will go to half in the time of half-life 20 minutes. 20 minutes half. So this one will go up to half value. And 40 minutes at the end of it, when this is 0, this one will be 1 and not wrong. So you should be able to plot some of the points and draw the sketch a graph. Okay.
Okay.
This is a marking scheme. How they will give you the mark. Line with positive gradient starting at 0, 0, and ending at extending to t equals 80 minute. Okay, 1 mark. Exponential curve extending from t equals 0, t equals 80, with a gradient of 30 decreasing magnitude. Okay, satisfied. Line passing through, they are looking for this point, this point, this point, and this point. Right? In between, it's difficult to calculate. Not that it cannot be calculated, it can be calculated, but they are not looking for that intermediate point. Explain with reference to radon random nature of radioactive decay why the activity of carbon-14 sample in B decreases with time. Yep.
Uh, a decay is the same for every undecayed nucleus. Fewer undecayed nuclei remain with time, which means fewer nuclei will now decay in a given time interval.
Every undecayed nucleus have the same probability of decay. Fewer undecayed nuclei remaining with time, so fewer will decay in a given time interval. Okay. State with reason whether a radiation detector placed near the sample of carbon-11 indicates a measured count rate from the sample that is less than, same as, or greater than the activity of the sample.
Less than. Because some emissions are absorbed before reaching the detector.
Sample emits in all direction, you detect in one direction only, but detector only capture emission in one direction. Some emissions are absorbed before reaching your detector. Yep, fair enough, you got it, 1 point. Some emissions are scattered within the sample. Simultaneous arrival of multiple particles only register once. Some particles may reach detector but not cause ionization. Okay, so any of these, we get 1 point. Say Hubler's law, identify any symbol that you use. Yep,
Hubble's law. Recession speed of a galaxy from an observer is directly proportional to the distance of the galaxy from observer. V equals H, not D.
speed is directly proportional to distance. Speed is the speed of recession of galaxy from the observer, and distance is the distance of galaxy from the observer. A star of luminosity 3.8 times 10 to the power 31 watt at distance of 1.8 and 10 to the power 24 meter from the Earth. Calculate the radiant flux at the Earth of the radiation emitted by the star. Just use a formula. Put in your value. This is your L. That's your distance. R is your distance. Calculate out. Okay. Determine the value of Hubble's constant. What formula do I use?
One is H naught over not H naught equals V over D.
Right? That's your formula. Right? You're given your wavelength. So V speed of the moving galaxy or receding galaxy. Okay, just go multiply and put in your value. Okay, 0.4.92 minus 4.86 divided by 4.86 times speed of light. And you get this one. And use Hubble's law. H naught. Okay. Any comment?
Okay.
Okay, then we carry on.
No.
The star is a distant galaxy. The spectral line in the light from the galaxy is known to have a wavelength of 486 nanometer. The spectral line in the light from the galaxy observed on the Earth has a wavelength of 492 nanometer. Explain why the wavelength observed on the Earth is different from the wavelength that the galaxy is known to have emitted. Yep. Why are these two values different? Yep.
Wavelength of light of the galaxy is increased due to redshift.
It's
Because the
moving away from the
galaxy has
Earth.
been moving away from Earth.
The wavelength of light from the galaxy increase by Doppler effect or due to redshift. Right? Remember, you must have 2 marks means 2 points. Determine the value of Hubble's constant. Right? We have done that lah. This one we're just repeating only.
Yeah, that already. Yeah.
Yeah, done that already. Repeating only. Okay. Okay, we have completed this one. Let's go to the next paper, 42. Found the paper?
Sure.
May, June 2023,
Sure.
variant 42.
Sure.
Found, huh? Okay, let's carry
Yeah.
on. State Newton's law of gravitation.
Force between 2 point masses directly proportional to the product of masses and inversely proportional to square this square separation.
Gravitation force is directly proportional to product of masses. Force between point masses. Point masses must be there. Not body, point masses is inversely proportional to the square of the separation. What does point masses mean? Yep. What does point masses mean?
Point masses.
Yep. What does point masses mean?
Like no volume. Like
No, it's just like a point mass. Basically, you see each other, like you see me and you as a point. So we are very far apart. So the idea of point masses is that the two bodies are too far apart. So the condition would be the distance between the body is very much greater than the size of the body. Then the body can be considered as point masses. Okay.
like meaning like you cannot
Basically, you see each other as a point. That means both of you must be very far apart lah, very far away lah.
Or like a dot lah, is it?
Like a point lah, like a dot,
Oh yeah.
but not quite a dot lah. It can still be a body there lah. But if you and me are
Oh
next together, then we are a body lah, not point masses. So if you are at
oh yeah.
Sunway, uh, Sunway College, and I'm at Palmview Villa or Subang Jaya, then we will see each other as a point mass. So the idea is
Oh.
the idea is that the distance is far apart between the two body, and the size of the body is smaller than the distance. No? Okay,
Hmm.
so far they haven't asked that lah. Doesn't mean they won't ask that. A satellite is in circular orbit around a planet. The radius of the orbit is r, and the period of the orbit is t. The planet is uniform sphere. Use the law of gravitation to show that r and t are related by 4 pi 4 pi square r square equals to gm square, where m is the mass and g is the gravitational constant. Very popular question. This is but they are now using it differently lah. They are not asking you to derive this one lah. This one used to be popular. So what is your first step? Yep, what is the first step?
What's that?
Yeah, first step to derive the
You take the
equation.
Fg equals Fc, the gravitational force equals the centripetal force.
Let the mass of satellite be m. Gravitation provides the centripetal force. This used to be worth 1 point lah, but these days they don't bother anymore lah. Right? Previous marking scheme will say 1 point for this, this must be there lah. Then put it there, cancel the mass, cancel r, then replace the v by 2 by r. Right? So there's your, this one they haven't cancelled the r, they cancel the m only. Oh, cancel the r already. So v square is 4 pi square, r square, t square. Okay, can
Okay. Yeah.
Earth may be considered to be a uniform sphere of mass 5.98 times 10 to the power 24 kilogram and radius 6.37 times 10 to the power 6 meter. A geostationary satellite is in orbit around the Earth. Use the expression in B to determine the height of the satellite above the Earth's surface. Right? Just using the formula you have derived. You want to find R from the center. R is from the center of the planet, of the Earth, to the satellite. So rewrite the equation, subject R, you put in your value, right? G 6.67 times 10 to the 11, mass of the Earth, T is 24, right? 24 hours, change it to second is times 3,600 and the whole thing square by 4 pi square. Use calculator, you get the answer, and minus your radius of the Earth to get height above the surface of the Earth, height. Can?
Okay.
Sorry, must put a unit there. Another satellite is in circular orbit around the Earth with the same orbital radius and period as in figure C, as a satellite in C. Calculate the angular speed of the satellite in orbit. Give a unit for your answer. So omega is 2 pi t, right? Same 24 hours, change to second, and 3,600 second. And you get that answer. Despite having the same orbital period, the orbit of satellite is not geostationary. Suggest two ways in which the orbit of the satellite could be different from the orbit of the satellite in C. Yep. Yep.
Like when the orbit is not equatorial.
Okay, it can be a polar orbit. Okay, 1 point. Yep.
Not from the same direction.
Instead of from west to east, it's going from east to west. Oh? Not equatorial or orbit is polar. Okay, can
Okay.
say what is meant by ideal gas.
No intermolecular forces.
No, they don't accept that.
Wait.
Even though
Oh, they don't accept that anymore.
previously they accept that lah.
Uh, the internal energy is
No internal
equals to
energy,
the kinetic energy,
just ideal gas equation.
and there's no potential energy.
No,
Hey,
correct, but they don't accept that anymore. Gas obeys PV proportional to T for all values of P, V, and T. T is the thermodynamic temperature. Okay? Say the temperature in
okay.
degrees Celsius for absolute
Hey,
zero.
teacher, when did they not allow this?
I think we have this is not
When?
time.
Oh, because the mark scheme is also some use the.
Some doesn't use this anymore. I think most of it doesn't
Oh,
use
I see.
anymore since 222. Previously, they accept that as authority, but now they don't accept it already. Ideal gas must obey the ideal gas equation at all pressure, volume, and temperature. And T is at thermodynamic temperature. That's important. Say the temperature in degrees Celsius of absolute zero.
Minus 273.15.
Okay. A seal vessel contains a mass of 0.0424 kilogram of ideal gas at 22.7 degrees Celsius. The pressure of the gas is 1.37 times 10 to the power 5 PA, and the volume of gas is 0.4640 meter cube. Calculate the number of molecules in the gas vessel. We got 10 more minutes. Okay, what formula to use?
Um, so PV equals nRT.
PV and KT. NRT will be giving number of mole. Then subject your n,
Oh yeah.
then substitute your value. That's your p value. That's your p value. That's your volume value. Okay, get from your data sheet. Temperature is 227 plus 273. Right? 273 enough lah. No need for 2.7315 lah. When you do such type of calculation, you can use that lah, but it's just a delay of your calculation. That's why you will get the same answer to three significant figure. Mass of one molecule of a gas, what formula to use?
This one is half m
That mass divided by the number of molecules, oh,
yeah,
right? Total mass divided by the number of molecules.
half good.
That's all. Root mean square,
Oh yeah. So
speed,
it's the
molecule.
half m square.
What formula to use?
Half m e wait. EK equals half mc square.
Half mc square equals to 3/2 kT. Then you want C root mean square. Sorry, just readjust the equation, that's all. Get that? Then put in your value, 3K 500. And then mass is what we have calculated previously. Can I get the answer? 2490. Mass is now cooled gradually to absolute zero. Sketch the variation with thermodynamic temperature of the root mean square, speed of the molecule of the gas. How does the graph look like?
Decreasing V.
This is a repeat question now. Like that, no? How do we justify it? How do we know the graph looks like? Right? Sketch is you square that lah. Basically, it's a square in this direction. No? It's a parabola in this direction, not in this direction. Okay. Marking scheme will be looking for 0, 0, and then 053 line. As long as there's a line. Even if you draw a straight line, I think you will get a point lah. Line with decreasing positive gradient, then you lose this point lah. If it's a straight line passing through the origin. Say the first law of thermodynamics. Identify the meaning of the symbol that is used. Yep.
Increase in internal energy equals work done in system plus energy transferred system by heating.
Change in energy equals to work done plus energy transfer by heating. Right, that's your first point. This is the latest one. You have to say the general statement first. Change in energy equals work done plus energy transfer by heating. Then this one is the actual one. Increase in energy equals to work done on the system plus heat transfer to the system by heating. The state of ideal gas is continuous change according to the cycle A, B, C, D. A, B, C, D, as shown in figure. Complete table 3.1 for changes A to B, A to B, and then B to C by placing two ticks in each of the row. Okay, AB, internal energy, increase, decrease, or change. Yep. Internal energy decrease, oh?
B to C. Wait,
Cannot be
B
the
to C
same.
is increase.
The temperature changes, so there's a decrease. You're going to the left is a decrease. And work done on the gas, positive, oh?
A to B positive, B to C 0.
Huh? B to C, internal energy,
Change in internal energy increase.
work done.
Work done is B to C is 0.
Okay, no? Use the first law of thermodynamics to describe and explain the energy transfer associated with a complete cycle. Can more work is done by the gas in CD than done at AB, right? More work is done. Yep. That part, more work is done than that part there. Overall change in internal energy is 0. Right? You go one round, one cycle, overall change in internal energy is 0. Must be an overall input of thermal energy. Right? So wherever you start and end at the same point, right? No change in internal energy. Overall input of internal thermal energy, if we start with A. Okay.
Okay.
A small steel sphere is oscillating vertically at the end of the spring as shown in figure 4.1. The speed v of the sphere varies with displacement x from the equivalent position according to the equation. V is in cm per second, x is in cm. Calculate the frequency of the equation. Right? Anytime will cut off lah. Right? If you can remember, good. If you cannot remember, refer to your formula sheet. Oh, right? Given.
Omega equals 2 pi F.
Omega, this omega. Omega is 2 pi f. Calculate out. Right? Put in your value. Calculate out. Show that the amplitude. Right? So this is the amplitude. Oh. Amplitude square equals 11.6. Is 3.4. Calculate the maximum acceleration. What formula to use? Yeah,
Amplitude of oscillations.
maximum amplitude, maximum acceleration. So you just
Yeah.
A omega square x.
A square, yeah. Omega
Then
square. Okay.
calculate out. Sketch a graph of acceleration A of the sphere